Next up, we have Sarah. Sarah is a well-known forensics expert. She works a lot with the government, doing all sorts of super interesting stuff that she probably can't talk a lot about. I'm very interested in her talk today. So let's give a round of applause for Sarah.
Okay, I just want to swap it in. Good. Finished it this morning.
It means it's fresh.
Yes, very fresh.
All right, Sarah, take it away.
Thank you. So I'm thrilled to be the second speaker at the event. I don't know if that's first loser or what, but I'll take it. So I'm Sarah Edwards. Like Patrick said, I'm a forensics analyst. I like to call myself a forensics nerd. I may look sweet and innocent. That's all fake. I'm pure evil, actually. So by day, I do government contracting for Parsons Corporation. In the evening and a bunch of weeks throughout the year, I'm a SANS instructor, author of Forensics 518, Mac and iOS Forensic Analysis and Incident Response. So pretty much what that means is I have no free time, and I spend a lot of time on computers, mostly Apple computers. But I'm mobile analyst by day, and then anything with a Mac logo at night. So this is my talk. It's from apple seeds to apple pie. It's pretty much a pattern of life talk. So when I'm doing analysis, and I'm going to go back and forth from Mac to iOS, probably focusing more or less on iOS because it's so intimate to our personal lives. I am looking for a lot of different things, anything from certain applications the person uses to a time frame, sometimes device usage, battery level, network usage, whether it's locked, whether it's unlocked, whether CarPlay is being used or not. You know, it really depends on the type of investigations. So Apple, thank you, Apple, for collecting an incredible amount of data. I frankly don't know why you're collecting this. I don't care as a forensic analyst, because I'm going to use it to my advantage. So we're going to be looking at quite a few different things here. So for this particular talk, in the description for the talk, I did not say that I was going to do a tool release because I honestly wasn't sure if I was or not. But one of my problems is actually doing the pattern of life analysis because there are so many different databases. It's so hard to get to some of these databases. So I'm going to kind of describe the problems that I've gone through first. And at the kind of the midway between the talk, I'll show you what I've come up with, a script and a couple of modules to actually automate some of this analysis because it will take a very long time to do. So the first problem is actually getting to the data itself, especially with iOS devices. These things are pretty locked down. I know we have a few jailbreakers in here, and I thank every one of you. I could not do any of my research from a physical level standpoint of these devices without those jailbreaks. So I'm not going to try to win ETA you anytime soon, but I do appreciate the jailbreaks.
Video issue that's going on.
What's with the weird alien sound?
Maybe just try plugging in and out.
Oh, I can't actually see that monitor.
Can you peek around the side?
Oh.
That's what's on the screen.
Yeah, that's less than useful. Computers are hard.
So it comes up after like 10 seconds for each slide, it kicks back. So keep our fingers crossed.
Okay, just flag me, because I can't see the screen because I'm too short to view over the podium. So I'll try to peek every once in a while, make sure it's there. All right, so the first part is getting access to the data. So I'm going to assume you have full physical access, and I don't mean physically on the device, but however you get onto the device, you have full physical access. You can access any files you want. It's not a backup. And I'm talking about different encryption things, so bypassing all of that. So I already assume a few steps into the process. From a forensic standpoint, I'm talking about using jailbreaks, and for my data, I do what's called, what I kind of term as a physical logical dump. So I'm on the device in the shell, and I'm basically tar bundling all the files on there. Other services, our Celebrite case service was pretty popular, and the new hot thing is Grayshift's Gray Key. I noticed a huge influx of investigators and people emailing me, asking me how to look at this physical access-based databases. Once that Gray Key came out, for a lot of law enforcement, it is fair game now to get access to a lot of these lovely databases that are usually protected from the iOS standpoint. So Gray Key is a big thing, good thing from a forensics perspective, maybe not so much from a personal security perspective. I kind of flip both hats. So yeah, we can talk about that a little bit later on. The next problem is the amount of data and correlating it all. So what I've gone through, and I will talk about a few of these databases here and there, some in more detail, some in less detail, but this is just a very small sampling of all the databases that are very forensically useful. And some of these can contain thousands, millions of different records. Some of them contain hundreds of different tables. I'm calling out PowerLog here, which has 250 some tables, all tracking a very specific thing. My new favorite database, the Knowledge C database, tracking every single thing that the user opens, every single app, every single, some little email thing. There's a ton of different things that it is recording. So just extracting all of these different things and then putting them together is kind of where I'm going with this talk. Otherwise, I'm opening each one of these in a SQLite browser, running separate queries, and then using that information. And that is extremely, extremely time intensive. So the next thing is building the queries. So it's great if I already have pre-built queries. I think every forensic analyst probably has some queries on their desktop in a text file somewhere that they use all the time, looking for very specific items in any number of these different databases. I certainly have plenty of my own. I've released a lot of them either through my class and through some GitHub websites and things like that. But doing the research and doing some of the correlation between some of these queries is extremely time intensive. Some are very clear cut. A table has a 0, it's a 1, it says locked or unlocked. That's pretty clear. But other ones you have to correlate across 3, 4, 5, 6 different tables to actually make sense of that data. And I'm going to call out the health database here because it's can get pretty complex with the amount of data being stored in there. Another problem that we're having is query validation and testing. So I can test things all day long, but I only have a certain amount of devices at my disposal and a certain amount of test data. You're going to find that with different devices, older devices, newer devices, point releases, things like that, that everything's going to be a little bit different. Databases change, the schemas certainly change over time. Apple loves to go ahead and rename some columns. So one query that was working for years, all of a sudden a point release comes out and boom, everything's broken. You got to go figure out what has changed. So devices, not necessarily equal, as well as platforms. So Mac and iOS, while they are so extremely close together from a forensics perspective, sometimes the database schemas are completely different. They're very similar, but they're still very different. And then I'd like to just point out some query sharing. So I have created upwards of, I think I'm at about 90 different queries for my particular script. And I'm going to share all of those. I'm still in the middle of testing some of those, but being able to share some of these queries with the community is really going to help different folks out. And testing some of that is also going to be part of the thing. So if a query works for me, it's not necessarily going to work for 10 other people. So we can kind of work together to make sure that we're pulling out the right appropriate data, and then that data means what we think it actually means. And this is where the testing and validation comes into play. I'd also like to point out that Alex Bergoni just started a GitHub page maybe a couple weeks ago to share a bunch of these queries. So as soon as I publish my queries, I hope they'll either be linked or ported over to his GitHub, and then we as a community can actually use these things to further our analysis. The next thing that's a problem is single-use scripts, and I've written plenty of these myself. You have a problem, you write a crappy Python script, and it solves it. It's not efficient, it's not great, sometimes it gets updated, sometimes it does not. So it's kind of one of those things where, yeah, it's great if it works, and if it doesn't, and the analyst doesn't know how to Python or program in Python, or to fix a variable, or to fix a query, or to do this, that, and the other thing, it's not going to be exactly helpful to anybody. So that's going to be another issue, and I think my script might solve that issue, but I'm kind of still in the testing phases. So let's see how this kind of works out. The next problem is we don't have time for this. As forensic analysts, and I'm different, I'm very much a research development kind of forensic analyst, which I have a lot of time to spend on things. I know everyone else that I work with, from law enforcement to government to your big accounting firms, everybody, they have a backlog of devices. They can't sit down there and build a query out that takes 8 hours to correlate and test and do all this stuff. It is extremely time intensive. So if somebody gets a case in, they get a gray key dump. They need to find the last 24 hours worth of locations on there. They're not going to go ahead and build a query for that. But if they can go to a GitHub website, pull it down, run it on that database, and get that information that's already been tested and validated and whatnot, that's going to help them. So speed is a concern in many of these, exigent circumstance and type cases. Also, analysts. They don't have necessarily the expertise to create the SQL queries or create a Python script or to do any of that. They just want to load it up within Blacklight or whatever forensic utility that they want, click the buttons, and make things work. The problem with a lot of those forensic suites is that they don't get into this level of detailed analysis. This is something that all those commercial products are pretty much losing. So you can click buttons all day long, but it's not going to show you what you want to do. You have to do this manually. And hopefully my script will at least automate some of that manual analysis so it can be a little bit quicker for you. And the next problem, timestamps and storage. Anybody who's worked with Apple data has probably experienced these same issues. In the variety of databases that I showed you before, there is a stupid amount of timestamps. Timestamps from a forensics perspective is great. I live and die by timestamps. But I also need to trust the timestamp. You'll see a couple of different storage formats, two most popular, Unix and Mac Epoch, sometimes right in the same database, right in two columns right next to each other. Consistency, not really a thing here. And then timestamps from the future. Thank you, PowerLog. You probably have seen PowerLog timestamps before, and if you've not looked on the actual device and tested it, they have been stored in the future. Sometimes they are stored in the past. So I'll show you a couple of examples of that, anywhere from 13 seconds in the past to up to 12 minutes in the future. From a forensics perspective, 12 minutes is a huge amount of time. You want to be extremely precise when you're doing some timeline analysis to determine where a user was. You can get a pretty far distance within 12 minutes or so. So that is something that I had to figure out. It's something that I'm still currently testing. And PowerLog is the main offender of that future timestamp thing. And then we have different databases like the Aggregate Dictionary and some other ones that store timestamps in a weird way. Either they're collecting data for an hour, so you have a per day, a per hour kind of thing, or it's just aggregating data on a per day basis, like the Aggregation Dictionary database. So timestamps are great, but they're just not as granular as they think they are because they aren't being used in that type of format. And then we have data storage. So every database is going to be a little bit different. There's embedded blobs, there's blobs everywhere. Usually blobs are full of just undocumented data formats, so we can kind of work our best to do that. Apple's not the best at documenting those formats, unfortunately. We'll see that in a little bit of the location data. We also get a bunch of embedded p-lists. Sometimes p-lists embedded with more p-lists, embedded with more p-lists, embedded with more p-lists. Thank you, Apple. That makes the forensic analyst absolutely crazy because you have to keep parsing to get down to that particular data. And then we get into weird things like the PowerLog has gzipped archive files. You'll have to unpack some of those to take a look at. And then just generally aggregated data. It's weird format. It's not on a per record, per timestamp kind of thing. So it's just strangely stored data. And then finally, the next problem is the unknown. Half the time it's data retention. So some of these are stored for 24 hours. Sometimes they're stored for 2 weeks. Sometimes they're stored for indefinitely. So I always like to say for a forensic analysis, get to that device, get to that dump as soon as humanly possible. Otherwise, that data is going to be flushed out of the system. If you need that last 24 hours of location data, you have to get to that within that 24-hour time span. Otherwise, it's going to be lost and gone forever. So it's really dependent on the type of data and which database that you're looking at. Another unknown thing is columns. Sometimes you see columns in there and you think you might know what they mean. A 0 is false or no, but sometimes in the world of Apple it's opposite. Or sometimes you'll see a 0 and a 4. What happened to 2 and 3? Don't know, but Apple pulls that crap all the time. Just one of those things to be aware of. So this is where testing on a live device comes into play. You can sanity check yourself, because I click this box, it shows up like this in the database. So different flags will certainly mean different things. And it's not exactly the most logical. And then finally, the units of measure. Again, different databases. Is it seconds? Is it bytes? Is it miles? Is it meters? Is it kilometers? Sometimes I don't even know what their actual unit of measure is. Sometimes it calls it out. Sometimes it doesn't. And then half the time, I don't know what Apple is doing. I try to explain what Apple is doing, and I can't. I don't know why they're collecting it. I don't know what it's being used for. Why are these timestamps stored in the future? Makes no sense to me, as it's a tracking database. But I still love you, and thank you for tracking and doing all the things that you're doing. So forensics people, we do love Apple. So a couple of examples of what I go through on a fairly daily basis. I bring up a database, I run a query, and I get outputted data. So a few examples I'm going to go through in a variety of these different databases. So first one is location. I like being creepy. I like stalking people through their location. It's very useful, and Apple does a ton of location tracking to various levels. So we can get into a lot of those different databases. So the newest one came out with iOS 11 called Significant Locations. You can actually look at it on your phone in your location services settings. And if you've never done so, I highly recommend doing it because it's extremely creepy. So of course, all of that has to be stored in a database somewhere. So Significant Locations has a set of 3 different databases, and it's stored amongst those. So it's got the cloud.SQLite, local.SQLite, and this one, which is cache.SQLite. So this cache.SQLite is storing the most granular of all the location data that I have found so far. So in my testing, I have seen this one to be storing about 7 days, 1 week worth of extremely granular data. That is very useful from a forensics perspective, as long as I can get to this data within that 7 days. So I have a query here, and I'm extracting some of these pieces out. I got my timestamp, again, very important. Coordinates, I've made it nice so you can copy and paste it into Google Maps. Altitude, course, speed, all that good stuff. So I can actually see if I'm moving or not through here as well, or if I'm just statically standing in place. So for this one, this is all my own data. So I know my own data pretty well, so I try to use it as examples as best as I can. For this particular output, I got about 40,000 data points for about a week's worth of location data. That's creepy. That is a lot of stuff. So of course, Apple is collecting this so it can help you determine, are you going to work, are you going home, traffic, all that good stuff. And it is being saved on the device. Love that database. Another one, which is kind of odd, is parking history. At least that's kind of what I'm coming up with on this one. This one's stored in the local SQLite. This one's kept for about 3 months or so. So it's trying to determine where you last parked. So if you forget where you parked your car at a big mall or something like that, you can go find it. So it's actually storing it historically, which I'm not entirely sure why, but I'm sure they have a great reason to do that. So I could figure out where I parked my car 3 months ago if I truly needed that information. Next one is more significant locations. This one is being more kind of called out from a user standpoint. So significant locations, if you're looking through that list, it's going to try to put a human name to a particular location, a local business, a street, things like that. So a lot of that type of information is going to be stored in this cloud.SQLite. So I have a few examples here. Got inbound, outbound kind of traffic, so you can see when you're going into the location, when you're exiting the location. And this particular example is actually one query. It's just very long, so I had to screenshot it and put it into 2 different screenshots. So I have inbound, I have the coordinates, the place ID, and the data points. So every place has an ID associated with it. So, actually the first one is my house, the second one is where I work, and so on and so forth. So I have, over 200 different data data locations, place IDs on my particular device. And the data point count is how many times has it seen it. So the more popular, it kind of gets shifted up the list a little bit in there. So visits, incoming, outgoing. It's also showing you what's recording that information. So I have it, this is all data from my iPhone 10. You can see that, the device class, the device model, when it learned of this location, and all these different timestamps I can use to start correlating when a user was at a certain location. It's not perfect, but this particular database actually goes back quite a few months. So I think when I last looked at this, I can see about the last 8 months or so of different locations. Now, it's not every single location I was, but it's the significant locations. So places that I've traveled to quite a bit. Now, another thing I want to mention is that data blob. So the place name blob and the place geo blob. Place name blob will actually give you that human name. This is an example when I was down in Virginia Beach taking one of the SANS classes. So we have these kind of proprietary blobs, and they're a little hard to parse out from a SQL query perspective. So my script actually will fail on a lot of this stuff, and I actually output it into a hex blob so I can throw it into a hex editor if need be. Now the place geo blob is actually very large, so I'm not going to show you an example of this, but you're going to see the reverse geolocation information for that particular area, all the Yelp reviews, mapping information, and all that stuff. So I can certainly show you some examples a little bit later on if you come talk to me during the conference. But I can only fit so much on a particular screenshot. So the next one I want to talk about is not location, but application usage. So it's really important to me on especially an iPhone device, what applications are being used and when. And the Knowledge C database is actually really useful for this. Again, it's one of my favorite databases, my new favorite database. Yes, that's a thing that I do. It's weird, but I'm a forensics nerd, what can I say? So knowledgec.db is storing every single app that I used for the last 4 weeks. Every single thing that came onto that screen, it's storing. The bundle ID information, it's actually keeping the day of the week and the GMT offset, so I can actually see some locational information here, different time zones being traveled. And the start and end time, and I did a little calculation to determine how long I was using that for. So this is extremely granular data. Can you remember what application you used 3.5 weeks ago at noon? No? I can tell you, because I just have to run this query. So pretty useful information, and I can just timeline this and get a good idea of how the user is using that device. What applications are they using the most often? Do they check Twitter in the morning, Facebook at night? I can run pattern analysis all day long on this type of data. For me, and I think it probably shows it here, the 489 seconds, of course that's Twitter. I'm on Twitter all day long, and my data actually shows that. So another one is in the power log. So it's actually kind of amazing to me to see redundant data being stored in multiple places. Not going to complain though, more data is better. I can filter it out. So it's very similar, but it's not being stored as long. For current power log, the app usage is being stored for about 3 days or so from what I've seen in my particular data set. So this is where those timestamps get really funky. So there's a time offset table in the power log, one of the 250 tables within the PowerLog PLSQL database. So I've taken a query, and I'm still testing to make sure it works, but I'm basically saying, hey, I have this set of timestamps, I have these offsets, and kind of marrying them up to make it a more realistic time frame. Because like I said before, 13 seconds, okay, maybe whatever, 13 seconds. But 12 minutes on some of my other older phones, that's going to be really significant from a criminal investigation perspective. 12 minutes is an extremely long time. So I want to make sure that I deal with those offsets in there. And this you'll see in a few different power log table examples. So I got the bundle ID. I pull out a few other different things like the orientation. Orientation of 1 is portrait, and 4 is landscape. What's 2 and 3? I don't know. I have absolutely no idea. And some of these other things, I just don't know what they mean, but I've extracted them anyway, just in case maybe the data can tell me what these things mean. So I have some adjusted timestamps and the originals in there as well. Now, apps being used. This one's going to be a little bit different, just another example of the previous screenshot. But instead, if you look at the orientation column, so the first one starts off at a 1, so COM Apple lock screen, that's obviously the lock screen, and then it just starts doing nulls. Where would I not be using the screen? If you take a look at some of the different bundle IDs in there, Springboard home screen, music, COM Apple CarPlay, OEM, I've plugged it into my car, and now I'm using CarPlay. So it's a nice little indicator that I can tell, was the user using this as the actual device, or were they using it through their car? So I've gotten a few people since I published my Knowledge C database blog that are doing accident reconstruction. So they want to see if this was a distracted driver. They can go to the Knowledge C database and see if they were doing, Facebook stuff, while they're in their car. You layer that location stuff on top of it, they can see if they were moving or not. So I've had a lot of folks say thank you for that, because they were able to say, yeah, this person was distracted, or they were tweeting, or they were doing something inappropriate while they were driving. And the data is basically leading them to this. So the next one is health data. I like to show this one. Again, this is my own personal data. So I can track heart rate. Why would I want to track heart rate? Well, it can get, again, really creepy, but I want to see if they're exerting some energy, let's say. So I did a talk at the SANS DFIR Summit all about the health database. We had one testing example where my colleague Heather Mahalik actually dragged a body across her lawn. It was her husband. Her husband's a pretty big guy. She actually got physically hurt during this. All for science. But you could see her heart rate go up while she was dragging it. So this can come into play in some criminal circumstances where something bad is happening, or if the heart rate goes down to 0. What does that mean? You kicked it, right? So you can kind of see the different differences in there. So I have an example of my data here for a very small time frame. That original quality was my heart rate at the time, and you see it's in the high 180s. I'm doing Orange Theory. I love my Orange Theory. This is at the end of class, basically running full out on a treadmill. I feel like I'm going to die at this point. So this is not my resting heart rate. This is me about to fall off a treadmill because I'm going to pass out really soon. So just a good example of that. And then you can, if you correlate this over the hour or so, you can see it raise and then go back down, and it's actually pretty accurate. Especially accurate if you have the Apple Watch, of course. The phone, of course, cannot track heart rate so much because when you turn on a workout on your watch, it's actually doing more heart rate, what's it called? Say that again? Yeah, it turns the scanner on, so you get the green blinky light. It's doing more sampling. So on a normal day, no workout, it maybe does a sample every minute or so, while during the workout, it's about every second or so. So you get quite a bit more data during that workout space. Next thing is just steps and distance. So if I'm not in a workout, I just want to see if they're walking or if they're running or if they're traveling between different places. And I have steps on the left and distance on the right, and they're pretty much being correlated at the same time. So you can see how many steps Apple think I took. Sometimes I see steps when I'm driving in my car. So again, maybe not the most accurate, but again, something I would like to test a little bit more. Actually see how many steps it takes and what Apple is actually recording that as. But as far as health data generally, from an Apple perspective, it's pretty darn accurate. It's just when I'm driving, maybe I'm driving too fast and it's getting recorded as steps. I'm a very aggressive driver. I probably cut a few of you off in the DC area. So next thing is device status. So what's going on with the particular device? Maybe not necessarily user-based stuff, but is it charging? Is it draining the battery? I can overlay this on a lot of different things. Oh, sorry, that was the next thing that I want to talk about. So this is what's playing. So when I'm in my car, I have CarPlay going on. I want to listen to music. I want to listen to a podcast, audiobook, whatever. For some reason, Knowledge C likes to see what's playing, and it's literally the stream name is now playing. So it's very accurate. So you can see on this one, I'm kind of bouncing back from Apple Music to NPR News. I am an NPR public radio fan, and you can see back and forth what I'm listening to at any given point in time. One thing I do want to point out here, and this again is my own music, don't judge me for my music tastes. We all have our guilty pleasures. So this one right here, can you see that? Okay, good. So this 30,000 whatever seconds, I'm listening to one song. That's actually really misleading. It's not that I'm listening to that same song. It's because I plugged it in my car, listened to a song, unplugged it, went to work for a while, and then went back into my car. And it's still calculating that usage time. So this is where you have to do some testing. You can't just make the assumptions that I was playing the same song over and over and over again. I might do that for some, but it does show that it looks a little bit different. So play around with that if you can. So next one is the device status. So I want to see when the thing was locked, when it was plugged in, and all the different device things about that. So that might come into play whether, application was being used by the users or was it just sitting on a desk somewhere. So the top one is showing me whether it was locked or unlocked, and the bottom one is showing me if it was plugged in or not. And then I can overlay this one on battery life to see the charging go up and down along with the plug and unplug status in there. Now, another device status is Passcode Unlocks or Face ID Unlocks. So on the left-hand side here, this is just another example of the aggregated dictionary one. This is the one that stores information on a per-day basis. So it's showing me how many times I unlocked my device with a PIN code. So this is coming from an iPhone 10, no Touch ID. So every once in a while, of course, it doesn't recognize my face or I'm yawning while I'm looking at my phone. I don't know how it doesn't recognize me at that point because I'm always yawning when I'm looking at my phone. But it'll show me how many different times I've unlocked that from a passcode. I had an investigator ask me about this one, send me an email. It's like, hey, is the passcode stored anywhere? Is changing of the passcode stored anywhere? And it is stored in the aggregate dictionary. So I can see what type of passcode it's using, 4, 6, complex, alphanumeric, whatever. Each one is tagged with a different number. But I can also see how many times that passcode was used. So this particular investigator had an instance where person got killed, was on her phone removing pictures, and then set up a passcode to probably try to disable the criminal analysis of that particular device. But they got into the device, they wanted to see when that passcode was changed from nothing to 4 or 6 digits or whatever. And you can see that within the aggregate dictionary. Now on the right-hand side, I'm looking for different scalars with fingerprint. Now remember, I'm on an iPhone 10. Nothing's going to come back with fingerprint. There is no fingerprint capability. There is no Touch ID capability. So this is where the device comes into play. So testing different devices, you're going to have different data because of just different security aspects of that device. So I've done a lot of the fingerprint analysis stuff before, but that's not going to come into play for this one. Now I did do a search for Face ID to see if it would recognize how many times I had a Face ID in there. And just doing a Face ID search within this does not come up with anything. So it might be named something else. Again, ongoing research, it truly never ends. I just need to be specifically looking for it and testing for it. Now, next up is the battery level. So when I did the locked, the unlocked, plugged in, not plugged in, of course I can overlay the battery level of that and see it going up and down. And battery level is going to be stored in a few different places. It's stored in the current power log, that's the example I'm giving you here, but it's also being stored in the knowledge seed database and amongst a few other places as well. So I can kind of correlate that between multiple databases. This is one of the easier tables to look at. It's just very simple. So that's a lot of data. That's a lot of queries, that's a lot of databases, that's a lot of testing, that's a lot of SQL query building. It takes time to do all that. So one of the things that I did, and I did this specifically for myself, though I will be releasing it to out into the world at some point, is I created a script to parse through all these databases. And I'm calling it Apollo, the Apple Pattern of Life Lazy Outputter. I think the name is fantastic. I created it because I wanted it to be a low bar to entry. So it's a stupid script. It really just takes a query, a database, matches them up, and dumps the output to either a CSV or a SQLite database. So I hope other forensic investigators, they have favorite queries, they can add modules, and we can kind of work with it there. So it's very useful for quick correlation. It's not pretty, it's not perfect, but it's easy to update and keep those queries up to date as well. So if you find something else that's useful, throw a module in there, and everything is good to go. So I guess I did say it's a dumb script. It's really not doing much. There's a few additional kind of analytic stuff that I like to throw in there, but that is really not done yet. It's really just based upon the SQL query modules. And I'll show you an example of one of those in just a bit. While I do call it the Apple pattern of life lazy outputter, it's just a database. It's SQL. So if you got an Android, a bunch of Android databases, does Windows use SQL databases? I honestly don't know. I don't touch Windows. But it really doesn't matter what platform it is, as long as it's a SQL database, SQLite database, and you have a query associated with it. So you can create modules for literally anything and just run it through. Now, the modules directory is just a directory full of little text files. I tried to make this thing as simple as possible. There's no really reason to overcomplicate things. So I already have 70 created, so I'll probably release about 70 later this week, maybe. But I have another 20 and 10 more in mind. So I'm probably going to have about 100 different queries once all is said and done. And I'm going to continuously update these as I do my research. As far as running it, it's just a Python script. Not really that difficult to run it. You just have to figure out which output you want. So CSV, SQL. If you have another output that you want, just let me know. It should be fairly easy to integrate into it. So an example of one of the configuration files. So it's just a text file. I'm using, config parser to actually parse this stuff out. Gives it a little bit of metadata information, who created it, a little bit about what it does or what it's extracting, points it to a specific database. So for this one, we got the Knowledge C database. What platform? So it's going to be very dependent on platform. So Knowledge C on Mac is not necessarily the same as Knowledge C on iOS. It's very close, but not exactly the same. And it's giving you some activity information, so when you're quickly scanning, you can see, okay, this is the application in focus, and a key timestamp. So this is all based upon a single timestamp. So whichever timestamp you prefer to kind of correlate all your data on there. So for this one, I did the start of the application in focus, or when that application became in focus. There's a few other timestamps. There's an end timestamp. There's a entry creation timestamp, but those are not accurate to what the user was doing. So this is where testing certainly comes into play. So running Apollo, and I'm sorry for the white on black here. I am using dark mode on Mojave. Still not entirely sure I like it, but it makes me feel like more of a hacker. So I got my script running here, and it's really just, it's going through all the different text files, every single one. If it doesn't find it, great. If it doesn't have the same database structure, it skips over it. And it's dumb. It's literally going through, doing just a recursive review, looking for that database name, and doing it over and over and over again, which means it's extremely inefficient, and I don't care. But just an example, once it's done, it says lazily outputted SQL file apollo.db, so I do the SQL database output. So I did this one on the plane yesterday, and we were landing very close to the time where this thing was supposed to finish. I was like, finish, before they make me put my laptop away. So this one on a full physical logical dump of my iPhone 10. Full dump, system, data partition, everything. It took 87 minutes to run. Really, really not efficient. So what I usually do is I'll just go and seek out those databases that I want, the knowledge, the power log, the this, the that, the other thing, and dump those into another directory, and it takes under 5 minutes to run. So this is where the file structure comes into play. I could say that I'm going to fix that, but I probably won't. I'll be perfectly honest with that. I'd rather write more SQLite modules for folks to run, and then they can, run this at night if they don't want to take the time to extract all the databases. I'm all about no promises here. So an example of the output. I got a few different screenshots here. I know it's ugly to look at, and it looks terrible in a presentation format, so if you actually want to sit down with me and kind of go through some of the data, there's only a certain amount that I can fit on here. So what you actually need is about 3 30-inch monitors pegged together with the SQLite database browser across all 3, because the data is just that long as an example. So it's really not meant for very small screens. So I have an example of this one here. So I took a day in my life on my iPhone, and that's September 16th, or Yeah, it looks like September 16th. And just sort of scrolled throughout the whole day. So I'm starting at midnight, so we get the 0-100 hours up there. And at this point, this is a Sunday, so it's a Saturday going into a Sunday at midnight on the East Coast. So I was leaving a friend's birthday party up in Maryland. So if you kind of look at the different application usage, you can see com 8bits tweety 2, which is Twitter, of course. You'll often see Twitter in my logs. So I was checking Twitter. Then I hooked up the phone to CarPlay. So a couple other items in here. You see the network usage, so you can see Twitter basically sending, receiving traffic back and forth. That could be very useful. But you also see the location information. So the different coordinates, I've redacted this because, well, it's my buddy's house. I don't exactly want to put that out to the world. But if anybody recognizes these coordinates, what, 39, negative 76, what state is that? Give or take. Everybody knows their own coordinates, right? 38, negative 77, no? Okay, so I am a nerd. This is Maryland, so it's right next door. And if you follow through, you can actually see where I'm driving and how to get home back to Arlington and the DC area. A few other things in device status. I see ComApple private alloy. That's a lot of the continuity stuff going back and forth, messages, receiving, all that kind of thing, so notifications, more location. And then finally over here, I see some more application activity. This is coming from the Knowledge C database. I get ComApple maps, dropped pin, and then directions from wherever. This is me in Apple Maps basically saying, send me home, send me to wherever. So I'm in CarPlay in the Maps application doing that kind of thing. So another example, this one you could see if it was distracted driving or not. So while I'm traveling, and you can see if I'm moving or not by looking at the location and specifically the speed, this is one thing that I'm actually curious about. And if anybody can answer this, that would help me out quite a bit. I don't know what the unit of measure of this is. So I know just from my normal driving that this is highway speeds, give or take. What 15 is, it doesn't seem to be kilometers. It's not anything that I can come up with. But it is highway level speeds here. So trying to take a closer look at that. And then you start seeing some app usage here. ComApple Assistant Service, ComApple Mobile SMS. So Assistant Service, this is Siri. So I have my phone hooked up into CarPlay, and I'm sending messages back and forth. So Siri is dictating my messages and sending them and doing all that kind of thing. So I can see if I was actually on the device itself, or was I doing the proper hands-free thing and using Siri. A few other things in here, application activity. I know it's probably a little difficult to read. We have the app name as messages and a bunch of intents. And if I keep going through and looking at the rest of the data on this line, you can see that I'm sending a message, so I'm using Siri to dictate it, but you can also see who I'm sending it to, how long it took, and all that additional metadata-based information. Again, I just can't fit it all on the same screen here. And then if I keep going, more location, more activities, listening to music, so ComApple Music, that now playing, so you can see what songs I'm listening to. You can actually see it bounce back and forth between Siri and playing music. So you can see how many different messages I'm going back and forth and that I'm rocking out during my late night drive. A few other things that might be useful in here is this Assistant D, ComApple Music, and I think somewhere it says Siri, or maybe I cut that off, but the ComApple audio information there as well. So no distracted driving. I was doing it all through CarPlay at this point. Next thing is device status. So couple of examples of that one. So a little bit later in the day, I'm looking at the battery life. I have different springboard things on here so I can see which screen I'm on, flipping back and forth. Different Wi-Fi information. So it's currently getting location from a variety of different sources. So I can tell what sources it's getting that location data from, whether it's cellular, whether it's the GPS chip, whether it's Wi-Fi, and so on. So that might give you a little hint on how accurate that location actually is. Keep going down. There's button types in here. Literally, a lot of buttons are tracked in here. Why? I don't know, but you'll see a lot of button events and everything happening. So I don't know what I was doing at that point. I can't remember. The screen brightness. So screen brightness going up, volume going up and down. A lot of different variables associated with the particular device are getting tracked here. And I'm not showing it to you here just because just different screenshots will just show different data. I think I'm not sure if I have it written anywhere, but for a day in the life of my phone, I'm looking at, oh, it's broke again. Oh, it's like it's going to sleep or something. All right. So this whole day is about 25,000 data points for a single day. That's a lot. That's a lot of scrolling within, your SQLite database browser. This apollo.db file, when I ran all my modules on it, come on. All right, is about 500 to 600 megs or so. So it's not a small database. This data get pretty large very quickly. Does it keep going out? All right, stand by. We were having a good run there for a second. Do you see it? Oh, I don't see it anymore. Oh, there it is. Okay. So a lot of different things having to do with what the device is currently doing. Another one is app usage and browsing. So this is where PowerLog app usage or Knowledge C app usage can come into play. So I can see what the user was doing, how long they were doing it, and in what order they were doing it. So this one, I see map lock screen, moving to Springboard home screen, to mobile mail, more mobile mail, Springboard. It's very hard to read. More device status stuff, mobile SMS, mobile Safari, more mobile Safari. So one thing that I didn't mention before is in the Knowledge C, it's also keeping track of my browsing history. Now this is separate from the Safari browsing history, the history.db stored elsewhere. Could I write a query for that? Absolutely, I already have a query for that. I just haven't implemented into this script framework yet. But I can grab that from the Knowledge C database as well. So thank you for being able to store that in multiple locations. Very useful from my standpoint. So I can see them doing different things with different application activities and application intents from specifically the Knowledge C database. Very, very useful to put context to what the user was actually doing. Were they reading an email? Were they sending a message? Were they browsing Safari? All sorts of useful information. So next up is more context. So there's specifically under Core Duet this Interactions C database, and this is going to give you a little bit more context on who I'm interacting with. So it's very much specific to things like communication or email or messaging and items like that. So with this one, I have a lot of examples of Apple mobile mail. I just happened to get an email sync at this particular time, so you can see a lot of the different emails that I've just received on my device. And a lot of it's just crap emails from Redfin, Audi, whatever else, Container Store. So it's a lot of junk mail, except for that one particular message that I redirected, because I'm certain that person wouldn't want their name on the screen here. So I can see interactions with that particular type of data. Next one is the heart rate. So going back to my workout, you can see with overlaying that location type of data and the workout information of where I work out. Maybe I'm running on a trail somewhere. I try not to run, but sometimes you have to. Oh gosh, this thing is being a beast. So I got some Twitter stuff in here, and finally I get some location information. So if you look up these coordinates, it's going to show you the location to Orange Theory in Ballston, Virginia. So if anybody wants to work out together, I'm there at 11:30 on the weekends because I like to sleep in. So I can see all the different heart rate things. So I can see when I go to class, see when the class starts, and see the heart rate go up, look like I'm about to die. And then at the end of the class, finally it kind of levels out. I'm not going to die, but I feel like I had a really good workout. So again, thousands of different data points for that. So you're really scrolling. I'm only giving you a small fraction of the particular data in here. Now, as far as improvements go, so I really wrote this script as something for myself because I want to automate this process. It actually takes, again, a long time to do this. Of course, I try to release as much as I can publicly, research, blogs, crappy Python scripts, because I want to help other investigators out there. So what I'm going to do is, one, I'll actually release it, hopefully this week sometime. Maybe, no promises. I want to write more queries for it. I can write, there's just an unlimited amount of queries that you can write for different aspects of Mac and iOS data. So more iOS stuff for sure, but I also want to parse some of the Mac OS stuff. So I really focused on iOS for this presentation, but a lot of this stuff is also being tracked on Mac OS. Not as much, but it's still useful from an investigative standpoint. I want to do more pattern of life stuff. I want to throw in more config files for different OS versions, so I want to try to get backwards compatibility at some point. Oh, thank you. So I want to get backwards compatibility, kind of update some of my old stuff. So I have some few older data sets. I can't do so much testing on some of those because I've updated those devices now. But I really want to get that out there just in case anybody else comes across it. So more testing, more efficiency at maybe doing the full file system dump. Maybe, not going to promise that one. Better blob display. So the location blobs I think are going to be particularly useful to just be quickly able to see what the contents of them are. So I might write some random strings kind of thing within my Python script to dump that out into the output. Since there doesn't seem to be a strings function within SQLite proper, at least not a good one. Embedded plist file extraction on archiving gzip files. So I want to start automating this so some investigators can just throw it at a dump, let it do its thing, and then get back all the data. Multiple database file names. So if the query is similar across platforms, I might try to merge that so it's less redundant. Still trying to figure that out. And then one problem I have is automatic database coalescing. So a lot of the times when we're dealing with forensic stuff, we have a shim, we have a wall. A lot of the transactions are being stored in those SQLite wall files, but I can't use that script to really do that. So if anybody has a good solution for that, I would really like to know. Because from a forensics perspective, that's a lot of data that I'm missing being stored in those wall files. And finally, I want to get some sort of visualization. So pattern of life, we need to have patterns of some sort. We need to be able to see what's going on across this. So this is a lot of data. I'm sure to break a lot of current visualization products. So it might be something I might have to write custom. I haven't thrown it into Splunk yet to see how that intakes it. But honestly, it should be possible at some point. And if anybody else wants to do that, feel free. Visualization is not really my thing. So this is not a perfect solution, but it's the solution that I came up with. It needs a lot of testing. Jesus. It needs a lot of testing. It's certainly not pretty. It doesn't work well for screenshots on here. It doesn't work well on laptop-sized screens, just because the amount of data that's being outputted to the screen. It's not fast, and it only works on SQL databases. Fortunately for me, Mac and mobile devices are all SQLite databases for the most part. So I'm not capturing some of the other data pieces in there. So I can't automate everything, but I can automate a big piece of what I have to go through. And then finally, mo data, mo problems. When I'm looking at some of this, there's, I think, 1.5 million entries in my particular data set. That's a lot of stuff to go through. No forensic analyst is going to scroll through that. They're going to start filtering. So I put a bunch of SQL databases into a SQL database, which maybe not makes the most sense, but it's the most efficient way that I can come up with. So now I can write additional queries to kind of filter this information or look through a time scope. So some event happened on this day. What are those actions? So I'm not going to go through the whole host of different data. Or I'm looking for activity for a certain app. I can filter on a bundle ID. Fortunately, Apple is pretty consistent on looking at application names or bundle IDs. So I can find every single time I open Twitter on my particular device. And finally, timestamps. I actually fixed a timestamp at 3:30 this morning because I was up, because in my mind, that's 9:30 on the East Coast. So you'll notice a lot of my queries have this weird date and time format. It's actually wrong. So I'm going to clean up this presentation, re-screenshot a lot of that, because I was getting everything off by 4 hours. I was like, what is going on here? Is it my laptop time that's off? I was trying to figure that out. And I figured it out at 3:30 this morning, wide awake. So I fixed that. I've changed a lot of the modules for it. And I've decided to output everything into UTC because it makes the most sense. So taking everything from UTC, if you want to bring it into local time on your own systems to do a little bit better analysis, you can certainly do that as well. So we can always have that timestamp fight at the bar a little bit later on. But UTC or GTFO. So thank you. I hope that wasn't too much data for everybody. I hope I didn't scare anybody. Actually, I do hope I scared everybody. It's kind of what I'm known for. And if anybody would like to deposit their iOS devices or Mac devices into my testing purposes, I will gladly take that. I always am looking for realistic data. So hopefully it'll be released eventually. I'm going to hang out at the pool for a little bit and try to do absolutely nothing. And then I have a really long flight to Sydney right after this. So it's 15 hours. I think I can clean up the code and then release it, hopefully, that next week. If you want to contact me, you can find me on Twitter. Certainly the easiest way is to find me on Twitter. You could email me too, but I won't respond. Usually I'm really bad at that. Or you can find me on my website, macforensics.com. And if you like looking at Mac data, take a class with me. I'm teaching in a bunch of places all over the world. I actually have a few students, old students here, quite a few more than I expected to see. So it's good to see everybody here and hang out and we can talk Mac stuff because I love it. I hope it kind of came across that I love it. It's truly my life. So thank you very much. Questions? And don't use my HDMI adapter, apparently. It's good for everything except this. Questions? Yeah. So the question is, have I seen any threat actors or I assume anybody trying to change the logs to make it look like they're not doing something? So it could be the user themselves or threat actors or whomever. It's not something that I've actually looked at, to be perfectly honest with you. My guess is that because there are SQL databases, you could go in there. You could actually go ahead and delete entries. I'm not sure what that would look like from a forensics perspective. Certainly worth taking a closer look at and giving it a try. But a lot of the times, this is where the kind of SQLite database comes into play, is where you can extract those records from within the deleted pages of the SQLite database. So if something kind of hinted at that, hey, something was cleaned up here or something is weird, that's the only reason I would start doing SQLite forensics, or if I see a certain string or something like that to do that. Otherwise, I'm already dealing with a whole host of data. I can't do SQLite-based forensics for every single database because it is particularly hard. Sanderson has, of course, a somewhat automated tool that I hear really good things about, but from my perspective, it's going to take some time to get that done. So it's not something I've actually looked into. Okay, so he says you need an entitlement to go ahead and delete things from the system. Yeah. Yeah. Yeah, I figured you need some sort of privileges to do that. Yes. Meters per second. Okay, I did not try that one. So core location speeds are meters per second. That is very good to know. Thank you, sir. I knew it seemed too small. I was certainly not driving slow. No. I'm an efficient driver. Oh, that depends. Okay, so the question was, have I ever encountered a jailbroken device through investigations? So the stuff that I do for work is I'm not getting devices in. I'm not getting that. So from all my students that I've talked to, yeah, some of them do get jailbroken devices, some of them do not. So it is fairly rare from what I've kind of come across, but it's certainly something to be concerned about. It could save you quite a lot of work from a forensics perspective. You don't have to jailbreak it yourself, and you can just get in there. With any luck, they didn't change the Alpine password, so boom, in. So it actually could be a benefit as well. But that also means they could have gone in themselves and changed things and done stuff and done whatever the heck they wanted, right? So, any other questions? Yeah. So question is, how do you deal with NS-keyed archiver p-lists? Suck it up. NS-keyed archiver p-lists are the bane of my forensic existence. So it's the serialized version of the binary p-list. Not super analyst friendly. You kind of have to parse them. I have a whole blog on how to parse these things. And for the most part, it's a manual process unless a lot of the tools have automatically done that. I haven't seen any scripts or, yeah. Yeah, so I haven't seen anything come out from a forensics perspective on how to pull those out, but I've not looked into it. But
ask an Objective-C developer.
Yeah, ask an Objective-C developer to make an NS-keyed archiver p-list parser.
There's also a Python script.
Yeah. Yeah, there's some of the Python scripts that I have played around with don't work for all of them, though. So I've seen a few of them be broken.
You have to make the class. You have to just set up the class that data came from.
Yeah.
Which sometimes are actually parts of the iOS already of the SDK.
Yeah.
If not, I mean, if it's in the one that's undocumented, it's probably pretty obvious what's supposed to be in it. So.
Right. Yeah, I usually go in there and manually take a look at it. You could write a script for each one, but each one is just a little bit different. So there's got to be a better method to do that, I would think.
So does Apollo right now have provisions for detecting the iOS version and using different modules or something like that?
No, that's way too smart. So the question was, does Apollo have any intelligence on whether it could figure out what version of the iOS or macOS it's using? And it does not. I'm not kidding when I say it's dumb. It's seriously dumb.
What about a property in the modules to enable or skip it based on the iOS version?
Oh, sure. I could put a lot more analysis into that to make it a lot smarter, but I wanted to do a proof of concept to make sure that I could actually use the data. That's the next step, next few steps, for sure. All right. Well, thank you very much, and I hope you all have a good lunch.
Awesome. Thank you, Sarah. That was a really excellent talk. I'm kind of paranoid to even stand this close to with my phone in my pocket. So keep your phones away from Sarah. We are going to have a lunch break now. There's a bunch of restaurants in the hotel, places to grab snacks. There's a mall right next door that has some options as well. We will be back at 1 p.m. for Richie's talk. So I know that's not the most amount of time, so try not to be late. Enjoy lunch.